But beneath this primal beauty simmers a hidden threat. 5 miles below the waterfalls and mountain peaks lies the heart of a supervolcano, a constantly moving cauldron of molten rock the size of Mount Everest. Over countless millions of years, it fills with lava to the breaking point. Like a bomb with a hidden timer, it finally explodes.
We don't know how long it's going to just sit there before it decides to go off.
If sometime in the future it were to erupt, as it has before, the Yellowstone volcano would overwhelm everything within 100 miles and disrupt lives across the globe for years. The first sign of trouble will be increasing seismic activity. The ground would rise as pressure from the molten rock begins to grow.
There would be a lot of ground deformation, and then if it was moving up slowly enough, we would actually start seeing large changes in the geyser basins.
Finally, the lava would shatter the Earth's surface with an explosion 10 times larger than Mount St. Helens. A hurricane of hot gases would spread out in all directions as the ash cloud reaches 80,000 feet into the air. Already larger than anything man has experienced, this would be just the beginning of a Yellowstone supereruption. Within days, a second enormous eruption would begin, then another. Soon, a ring of monstrous explosions 50 miles wide would be spewing molten rock and burning gases across the landscape.
Certainly within 100 miles of Yellowstone, there wouldn't be much that was not destroyed.
High in the atmosphere, the ash cloud would surround the planet, sending temperatures plunging. Global agriculture would fall into chaos. How do we know it will happen? Because it's happened before. The evidence is etched into the geologic record of past supervolcanoes. There are 1,500 volcanoes around the world. But there are fewer than 10 supervolcanoes, the ones with the potential to not only destroy the surrounding area, but to create a global disaster. And Yellowstone is one of these supervolcanoes. Unlike a conventional volcano with its crater atop a mountain, Yellowstone's crater is so large it can only be seen from the air. This is the rim of a monstrous crater called a caldera that collapsed into the magma chamber during the last supereruption. It's large enough to hold the city of Los Angeles. And this is only the last of 3 monstrous calderas formed over the past 2 million years.
The first eruption vented somewhere around 600 cubic miles of material. And if you took all of that and you spread it out over the state of Texas, you'd have about 12 feet thick of deposits.
The second eruption was hundreds of times larger than Mount St. Helens, and it's the smallest of the Yellowstone supereruptions. The most recent one, known as the Lava Creek eruption, occurred 640,000 years ago.
Typically, when these eruptions begin, they begin at a single vent, and the event may then get larger, moving out along some sort of a fracture system.
Yellowstone's last supereruption occurred 640,000 years ago. It started as a single massive volcano, but soon turned into a series of eruptions, exploding with the full force of a supervolcano.
The entire sequence of pyroclastic explosions that formed the Yellowstone caldera may have taken as little as 2 weeks to happen.
Pyroclastic flows slashed across the landscape, obliterating thousands of square miles. Separate clouds of ash fused into a massive column of smoke. Winds drove it across the country, darkening the sky for hundreds of miles.
During the eruption of all this material, that's when the caldera would have started forming.
In a final massive display of nature's fury, hundreds of square miles of mountain dropped thousands of feet into the pit of roiling magma.
The Gallatin Range and the Madison Range and the Mount Washburn Range to the north continued somewhere into the Yellowstone region. These mountain ranges were destroyed. Now, when I say destroyed, I don't mean they were blown to smithereens into the atmosphere. Much of it just fell back into the magmatic system, just fell back into the cauldron, if you wish, up the caldera itself.
We're talking about mountains that might be 12,000 feet high that are now the ground surface is on the order of 8,000 to 9,000 feet high. So 3,000-foot mountain that is no longer there.
Finally, after perhaps weeks of constant activity, the Yellowstone volcano subsided. But the devastation was far from over. A global disaster was about to begin. 2.5 trillion tons of sterile volcanic ash drifted with the winds and buried 2,000 square miles of the North American plains, destroying much of the continent's plant life.
The volcanic ash that's ejected high up into the atmosphere and then falls many, many miles away, that goes as far as Louisiana and some of the states along the Mississippi River. So quite an ash cloud.
The lighter particles remained in the air for more than a year, forcing temperatures to plunge across the hemisphere.
It acts as a veil and cuts out the sunlight, and so it cools the climate below. I think there would certainly have been climatic changes due to Yellowstone. We estimated 3 to 5 degrees Celsius drop in temperature, which is quite severe on a global basis.
5 degrees was enough to kill off much of the tropical plant life across the globe. Over the next year, animals died from lack of food as the ash continued to block out the sun. It took years for the planet to recover, for sunlight to reach the Earth's surface, for plants to push through the layers of ash, for animals to repopulate the continent. This Yellowstone eruption 640,000 years ago changed the face of North America. But that wasn't the only supereruption to ever strike the area. Besides the 3 calderas found near Yellowstone Park, geologists have discovered a series of eruptions and supereruptions that extend back 16 million years.
There have been a series of volcanic eruptions similar to those that occur at Yellowstone, and there are all sorts of calderas that are preserved in the Snake River Plain in Idaho and extending back into Nevada.
To date, 15 calderas of more than 140 large eruptions have been mapped. They create a trail running northeast to southwest and are an indication of what geologists call a hotspot. A hotspot is a portion of the Earth's mantle that contains a massive pool of partly molten rock.
There is an area within the Earth's mantle, deep underneath where we live, that is molten, and it's causing a lot of heat to rise towards the surface, and that heat causes melting in the crust, and so we get large magma chambers.
From time to time, as the pressures build, the magma works its way to the surface and explodes. Above its magma chamber, the North American plate is slowly sliding to the southwest, about an inch a year. With each new eruption, a caldera is formed and appears to be further to the north.
We find calderas all the way back into northern Nevada, and it's possible that there have been as many as 50 eruptions, just as big as some of the ones that have come out of Yellowstone.
With a history of multiple cataclysmic eruptions, Yellowstone is becoming the most studied supervolcano in the world, and its hundreds of yearly earthquakes, thousands of geysers, and massive magma chamber make it one of the most geologically active regions.
This thing is a breathing system, and it's a dynamic system. So I called it a living, breathing, shaking caldera.
Rock rising from deep within the Earth, but no one could be sure. Recently, however, scientists have been using extremely sensitive monitoring systems to capture data from earthquakes centered around the world. The data has helped create the first 3D image of the source of Yellowstone's power.
Once we put out an array of seismographs with sufficient resolutions, like getting a high-resolution CAT scan, we saw that this thing was going off laterally about 150 kilometers to the northwest, and it is basically coming up from a depth of about 600 kilometers.
Yellowstone's magma source begins 450 miles below the surface. and surprisingly not directly under the park, but 150 miles away beneath the Montana-Idaho border.
It was totally unexpected and would not fit into anyone's textbooks or classic ideas.
One thing is known for sure. If Yellowstone erupts again, pyroclastic flows will destroy everything near the volcano, and its ash cloud would overwhelm humanity across the globe, and predicting its eruption could be a matter of life and death. The 1991 eruption of Mount Pinatubo in the Philippines, which devoured villages out to 200 miles. Yet despite its modest size, Pinatubo altered the global climate for years and has been linked to the destructive hurricanes Andrew and Iniki.
After the eruption of Pinatubo, there was a definitely measurable change in the global temperature as a result of that eruption. It was on the order of 2 degrees for the year following the eruption.
It may sound trivial, but a 2-degree change in global temperature over a long time could create unusually severe storms and kill off all but the hardiest plant life. Pinatubo was 100 times smaller than the last Yellowstone supereruption and had cataclysmic effects across the globe. Imagine what Yellowstone would do. In recent geological history, only the colossal eruption of Toba on the island of Sumatra can match the size of Yellowstone. And that eruption some 70,000 years ago may have nearly destroyed the human race.
Well, Toba is the largest supervolcano that we know about. There's now a large lake called Lake Toba, which is the hole out of which the eruption came.
It likely erupted for 2 weeks, dropping ash 6 inches deep on the subcontinent of India. But Toba's greatest impact was felt halfway across the planet in Africa. Around the time of the Toba eruption, it's thought the population of early man was catastrophically reduced. It appears a bottleneck or a contraction of the human population occurred, reducing our numbers from possibly hundreds of thousands to just a few thousand.
We know from the genetic data that something happened in the human history, in the history of our species, that reduced the amount of genetic variation a lot. And the argument is all about what was the nature of that event. One possibility is that there's some catastrophe that happened 70,000 years ago, like the Toba supervolcano, that just wipes out plants and animals and humans all over the earth until there's hardly any of them left.
The massive eruption of Toba, more than 25 times larger than Tambora, likely created a catastrophic change in climate. Ice core samples suggest that the average temperature may have dipped as much as 20 degrees for years after the eruption, likely killing off plant life across the globe. Hardest hit would have been tropical areas like Africa.
Africa is where we were at the time, and so it would affect us directly. And secondly, it's the tropical vegetation that never experiences cold temperatures, so has no adaptations for cold temperatures whatsoever.
The frigid temperatures killed off much of the African plant life, and the resulting famine may have decimated much of the human race. It may be that the 6.5 billion people who inhabit the Earth today are the direct descendants of the few who survived the Toba eruption. If a single eruption like Toba is powerful enough to almost destroy the human race, what would a similar supervolcano do today?
When a large giant eruption were to occur, I think there's little that man can do about it. The biggest thing we have to do first is understand them.
That's why scientists are studying every aspect of the Yellowstone volcano. What they discover may be the key to our survival. Park 12 global positioning satellite monitoring stations that can detect ground movements within a quarter of an inch. Geologists have also gained a bird's eye view of the situation.
We use satellites in this case to take pictures of the ground as it's moving over time. And so we can compare 2 different passes of the satellite that are perhaps a year apart and make a map of how much different spots on the ground have moved.
With these tools, geologists have been able to document changes in the caldera, its constant rising and falling over time. According to recent satellite data, much of the caldera is being lifted up.
What we've seen has been uplifting now at rates of 6 to 8 centimeters per year. Those are very high rates.
The most dramatic uplift is just north of Yellowstone Lake, in the area geologists call a resurgent dome.
And we have within this caldera these orange areas here. These are resurgent domes. These are areas that are uplifted while the caldera was collapsing and subsiding.
Geologists believe that these two areas were lifted up by the magma chamber as the caldera was formed. It's thought that some magma is still inside these domes, holding up these areas. But they couldn't be sure until now. We've seen this model of the Yellowstone magma plume, the tube through which molten rock from the Earth's core reaches the magma chamber sitting on top of the plume. Using similar data, geologists have created this 3D illustration of the magma chamber as it sits below the Yellowstone caldera.
This is a three-dimensional image like a CAT scan or an X-ray of the Earth. It is giving us an image of what we think is the magma system that drives Yellowstone.
This U-shaped chamber is thought to contain more than 300 cubic miles of partially molten rock, 100 times larger than Pinatubo's magma chamber, and is just 5 miles below the surface. More importantly, the area of the most dramatic uplift spotted by the satellites is directly above a peak of the chamber. This suggests the magma chamber is expanding, pushing up against the Earth's surface at this peak. The other area of striking ground deformation is near the Norris Geyser Basin, the hottest and most unstable thermal basin in the park.
Norris Geyser Basin is one of the most dynamic of the hydrothermal areas at Yellowstone. It's always changing. We're always noticing new things that are happening.
Just a few years ago, satellite images showed Yellowstone's greatest rise in this area. Recently, however, it's reversed its direction and is now subsiding.
It's not actually within the Yellowstone caldera, yet it's one of the highest temperature thermal areas in the park. And it is possible that there is some magma extending to the north beneath that region.
The source of the basin's volatility could be magma, or another key component to volcanic activity, earthquakes.
The earthquakes are essentially the heartbeat of the system. They're an integral part of the active, if you wish, mountain building and volcanism of Yellowstone.
Like smoke and fire, volcanoes and earthquakes go hand in hand. The pressure from the magma, which can explode into a volcano, also forces the ground to shift, causing earthquakes. They can be the telltale signs of an impending eruption.
The two main precursors to a volcanic eruption, seismicity and ground deformation, are very carefully monitored in Yellowstone.
In this computer model, each red dot represents an earthquake. Typically, hundreds of earthquakes are detected across the park each year. In recent years, the greatest earthquake activity has been centered under two areas of the park.
Well, you can see we have earthquakes that are concentrated on the north side of Yellowstone coming down through the park and then out extending on the east side of the Teton Fault right here.
What concerns geologists is when a center of earthquake activity overlaps an area of shifting terrain. At the Norris Geyser Basin, that seems to be what's happening. There are dozens of fault lines at this spot.
That's very critical because if magma is starting to move up, we would expect to see a bulging in an area and associated earthquakes as the ground starts to crack.
The fear is faults that make up the earthquake zone could crack under pressure from the magma below, releasing an eruption. Geologists are also watching the park's geysers, hot springs, and mud pots, looking for drastic changes in temperatures and chemical content. Anything that might indicate a major movement of magma. At the moment, geologists do not believe an eruption is imminent. But if the water temperatures were to rise, the ground begin to swell, or there were an increase in earthquake activity, another Yellowstone eruption could be building.
I think that we are smart enough as geoscientists now that we would probably have weeks to perhaps months of indicators before anything like that would occur.
However, predicting the precise timing of an eruption is far from simple. Scientists have been fooled in the past.
We've seen it in Yellowstone. There's bulging, there's vibrations, there's increased seismicity. There's all the things one would expect and go, oh, uh-oh, we're in trouble. And then, nothing.
It may not happen for thousands of years, but one day history will repeat itself. The slumber of the Yellowstone caldera will end, and the planet will face potential catastrophe. Hopefully by then we'll be prepared. But if not, it could be one of nature's greatest mega disasters.